Good morning. So we'll continue on chapter 12, multiple access techniques. We started by carrier system multiple access last time, and we talked about the different persistent methods that used with carrier system multiple access to define when what should station do if the channel is busy and what should the station do if the channel is ideal. Then we talked about first enhancement over carrier system multiple access, which is carrier system multiple access with collision detection, where we can detect a collision before the end of the transmission. So each station, if detects a collision, we can stop the transmission once we detect this collision, and we see that this collision can be detected using energy levels. And in this case, we should have minimum transmission time or minimum frame size to detect a collision and stop the transmission before ending the transmission. يعني we should detect a collision, and we can use a received energy level to detect if we have frame transmission, if the channel is busy or if the channel is ideal, or if there is a collision. Okay. Now in this case, in the next enhancement in carrier system multiple access is carrier system multiple access with collision avoidance. So instead of let the collision happen, then we detect it, then we try to avoid it. Now we need to avoid the collision from the beginning. Okay, because detection of the collision is still part of challenging to detect the collision accurately. So it's better to try to avoid the collision from the beginning before starting transmission. So how we can, what the main idea of collision avoidance over SISMA? We will use three things: interframe space and contention window and acknowledgement. So now we'll make this small modification of our Prisma. First, we continuously sense the channel. If it's busy, I'm stop transmission. I will don't do anything. I will not do anything. Once I found the channel is ideal, I will not transmit directly. I will wait for enter frame space, IFS time. Why should I wait this time? To avoid if there is multiple station, if there are multiple station need to transmit at the same time. So if we all sense at the same time, we found this channel busy. Once if two stations find the channel idle at the same time, they can transmit at the same time. So to avoid this, we will wait. Each station should wait inter-frame space time, IFS time, and this IFS time different from one station to another. For example, one station can wait for 1 millisecond, other station can wait for 2 milliseconds, and so on. So it's not fixed for all stations. Each station will have its own interframe space-time. Okay. After this interframe space-time, for extra to be conservative more, I will also wait for contention window. There is contention window. Okay. So each station will choose random number of slots to wait from this contention window. So in contention window, there is small slots. These slots, طبعا small are slots, and each station will select أو N slots. Each station will select R slots to wait from this contentional window. This is for extra conservative approach. So each station will wait interframe spacing and will wait random number of slots in the contentional window. Then if after all of this channel is still ideal, I will send my frame. It means that no one is also trying to send with me. So I will send the frame. If I found the channel is busy, I will stop and continue later. Okay. So when an ideal channel is found, the station doesn't send immediately. It will wait first for a period of time called an interframe space. This interframe space can be used to define priority between frames. Why? And each station is not it's not a fixed amount for all station. IFS is defined per station. So each station can have different waiting time or different interframe space time. So the stations. So I can use this benefits to give priority for the stations. If one station has high priority, the IFS for this station should be large or small. If I need to give for one station high priority to transmit, so the IFS should be small or high for this. Small, exactly, because I give here high priority, so I need this station to transmit first. So I will give here, or I give this station small amount of time to wait or small IFS, so this station can transmit first, and other station will wait for longer interframe space time. And once طبعا this station start to transmit, the channel will be busy, so all stations will stop. So this waiting time, the IFS time, I can use it for giving priority to different stations. So if a station assigns shorter IFS time, it means it has high priority. It can transmit first. Okay. Right. What about the contention window? Contention window is the amount of time divided into slots. So contention window, for example, can have n slots, and each station is ready to send will choose random number of slots to wait. Something similar to الباك اوف strategy. يعني الباك اوف احنا what we did in the back of each station. Once the frame is lost, we'll wait for timeout, then we'll wait for random amount of time according to number of retransmission. If I retransmit it more, I will wait more. It means that the channel is busy, so I have to wait more. Once I retransmit again, I will wait more, and so on. This is back of time. This is similar to contention window. I will also choose random number of slots to wait. And why random? To try to avoid in two stations choose the same number of slots so they can transmit at the same time. So after waiting the IFS time, each station will wait again a random number of slots through the contention window before starting transmission. So each station will wait for two amount of time, IFS time, then random number of slots during the contention window. Okay, right. But what station do bad during this period? The station is always sensing the channel during this period. So sensing at the beginning, if the channel is busy, it should wait. After the channel is ideal and during the IFS time, I am also sensing, because during the IFS time maybe another station start to send before me, so I have to stop. So during the IFS time, each station should also sensing the medium. If it's still ideal, I will continue. Then during the contention window also, I should sense the medium. If it's ideal, I will continue my timer until the end of contention window. لو random number of slots each station choose, I will wait until the end of the timer and start to transmit. But if in any stage بقى IFS time or the contention window, I suddenly found the channel busy, I will stop my timer, but don't restart this timer. I will continue this timer later once the channel is idle again. So for example, if during the contention window, I wait for the IFS time, and during contention window, I choose random number of slots, for example, 3 slots. So I should wait for another 3 slots before transmission. Here I'm sensing it's idle. Here sense it's idle. Here sense it's idle. But here, مثلا, in second slot, I found it busy. The channel become busy now. So I will stop. I will stop my timer. But I will keep sensing the channel. Once the channel is idle again, I will not restart from the beginning. I will just continue my timer. So what's remaining for me? Only another one slot, then I will start transmit. So I will, during the quotation window, if I found the channel is busy, I will pause my timer or stop my timer, but not restart it. And I will continue timer again once the channel become free again. طب why بقى I didn't restart my timer? Because it's not fair. يعني I already waited for a long time for the channel to be idle. And another station يعني take the channel before me. So once this station leave the channel, I should take the priority now. I should continue my timer and start to transmit it. It's not fair to restart again from the beginning and another station take already waited for a long time. So I have to continue my timer and start to transmit once the channel is ideal. So if the channel finds the channel busy during the contention window, it doesn't restart the timer. It's very important. It doesn't restart the timer. It pauses the timer and run it again when the channel become idle. Okay. So now, what collision avoidance? What is the strategy collision avoidance did to try to avoid the collision from the beginning? Make two things. First, each station will wait for interframe space time, and this time different from one station to another. So each station can take different interframe space time. So will not have the same time. So visibility in the two station transmit is low. Even more, I will choose each station will choose random number of slots inside the potential window to wait. So again, it's another conservative way to avoid in the two station transmit at the same time. After all this bad procedure, most probably the channel will, if the channel is still idle, most probably no one is sensing. So I will transmit and I will take the channel. Any bad station try to send later will find this channel busy. So by these two methods or two steps, I am try to guarantee that the channel there aren't two stations transmit at the same time. يعني المين idea of collision avoidance is try to avoid ان two station transmit at the same time. Okay. And during the contention window, if the channel become busy, I will just pause my timer and continue it or run it again once the channel become free again. This is the flow chart or flow diagram of the main steps of SISMA CA. At the beginning, I will start with k equal to 0. This is my first trier. K is number of triers to send. I will sense the channel, keep sensing the channel continuously. Once the channel is ideal, I will wait for the interframe space time. Okay, and this time again, different from one station to another. It's not constant for all stations. And I will sense again, channel is still ideal, so I will start my contentional window. Contentional window, I will choose random number R. With this random number R again, like the backup procedure, between 0 and 2 to the power k minus 1. Why 2 to the power k minus 1 between 0 and 2 to the power k minus 1? And k number of retransmissions. But if retransmission is high, it means that I have to wait longer time and the channel busy. But if the retransmission is low, it means that the channel is not busy, so I can quickly choose يعني wait for a small time, since I will start directly. I don't have to wait for a long time because there is no possibility for transmission. I sent several times before and I found the channel is empty and no retransmission. But once I retransmit one time and more, so it means that the channel is busy, so I have to increase my contention window until the channel become free. So I will choose random number R between 0 and 2 to the power k minus 1, with k in number of attempts or number of retransmission times. Then I will, once I choose this random number of slots, I will wait this R slots. This is my potential window. And here IFS time, I'm waiting first IFS time, then I will wait potential window. اللي هي contains R slots, well R is random. If the channel is still ideal after all this, if the channel is still ideal, I will send my frame. Once I send the frame, I will wait for timeout as usual. If I received an acknowledgement, it means that the transmission is success. If I didn't receive acknowledgement, I will retransmit. So I will increment my attempt. This is my second attempt. I will retransmit. If I didn't reach to the maximum number of retransmission times or maximum number of attempts, I will repeat everything again. I will test channel again and try to resend or retransmit my frame again. Okay, these steps is clear. Okay, so the channel needs to be sensed before and after IFS time, and the channel also sensed during a contention window. This is the first note. Second note, for each time slot of contention window, the channel is sensed at each time slot. If it's ideal, the timer contains. If it's the channel found busy, those timer will stop and continue after becoming the channel ideal again. Okay? Any question in Sysma? Mm. So we started at the beginning characteristic multiple axis, يعني pure characteristic multiple axis, and we studied three main methods to sense and transmit my frame, the three persistent method. Then we make the first enhancement with collision detection, and I defined according to signal level, if a station detect a collision, it can stop transmission, and we define the minimum frame size to detect a collision and the minimum transmission time to detect a collision. Then in collision avoidance, we did two changes. Each station after finding the channel is ideal will wait interframe space time, and after that we'll wait for contentional window or R slots, where R is the random number. So I will wait for another random number of slots before start transmission. So this يعني three steps or three enhancement in carrier sensing multiple access. Any question? If you remember from the beginning, we said that the multiple access technique in this chapter divided into three categories. First category is random access, and we study under this category Aloha, stored Aloha, pure Aloha, stored Aloha, carrier sensing with collision detection and collision avoidance. All this was random access technique. Each station transmit randomly without any coordination with other nodes. In all previous techniques, Aloha and Sysma, did any station talk with other stations or coordinate with other stations? No. Is there any controller or central nodes that controls the system? No. Each station run its own algorithm and takes the decision alone and start to send or not send according to its own algorithm. There is no coordination between nodes, and there is no central controller or control nodes that take مثلا take action to try to coordinate between nodes. But all previous technique were random access techniques. Now we'll move to the second category, which is controlled access. So in controlled access, there will be a centralized controller. So if you have multiple nodes share the same link, there will be مثلا this node 1, 2, 3, there will be a central controller. For example, node 3 will choose node 3 to be a central controller. And node 3 will define if station 1 should transmit or station 2 should transmit. So there will be a central control now. In previous techniques, لا, can each node decide alone if I will transmit or not. Now, with central controller, for central controller will make coordination between different nodes. Like in this, with this idea. No, لأن خلاص يعني في central controller define who to send. فده is at the same time. لأن one node define who should send. But it will not give permission to two stations. So there is no possibility يعني in control access بقى عند ال different third category اللي will talk about ال channel access techniques. There is no possibility of collision because there is a coordination between nodes. Stations in this case will consult another station central station to find which station had the right to send. And station can't send unless it had authorized or take permission to send. So each station should take permission to send. And under this category, controlled access techniques, there is two techniques, reservation techniques and pooling technique. So in reservation techniques, station to each station need to transmit will make a reservation before sending the data. So unlike random techniques, each station has data to send, can send. Now, لا. Each station need to send. In the reservation technique, each station has data to send, should make a reservation before sending the data. طب how the station can make this reservation? We define a reservation frame. There is a short frame, very short frame with very short slots. I define this frame into slots, and each station needs to send will reserve. There is 5 slots here. Station 1 needs to send will reserve the first slot. So we'll send during the reservation frame. I need to send in the first slot. So this is reserved for station 1 to send. And this طبعا frame will be broadcasted to all nodes. So all nodes خلاص will know that first slot is reserved for station 1. Station 4 need to send will reserve another slot to send. Station 3 reserve this slot to send. So during this reservation frame, each station need to send will reserve a specific slot or a specific time to send during this time. And all other stations will stop طبعا transmitting. But once this slot, the first slot is reserved for station 1, all other stations will stop transmitting. Only station 1 will be permitted to send during this slot. But the idea of reservation techniques is very simple. Any station need to send should make a reservation during a reservation frame and should reserve a specific slot or specific number of slots to send during this time. But if we have n station in the system or n station are sharing the same link, so we'll have n reservation mini slots. This reservation frame has many slots and it's this very short slot لأن large slot during transmission, but this is just for reservation, so it's many slots, very small slot in the reservation frame, and we'll have n reservation mini slots, but each mini slot will belong to a specific station. When a station needs to send the data frame, it will make a reservation in its own mini slots. فخلاص station 1 will be reserved the first mini slot. It means that in the first transmission slot, station 1 will transmit, and so on. And مثلا the third mini slot will be reserved for station 3, so in the third slot, station 3 will send, and so on. So each station will, if you have n stations sharing the same link, we will formulate reservation frame from n mini slots, and each station will be allocated specific time to transmit during this time and can't send in any other time. It will only send during the reserved time. So there is no possibility of collision and take permission before transmit. But this is the main idea of reservation technique. Right. What's the disadvantage of this technique? Yeah, yes, we add some complexity because we need central controller that manage this system. So it adds some complexity. What another advantage? Avoid collision دي الادفانتج. فالادفانتج of this technique ان احنا we avoid collision. There is no possibility of collision. الديسادفانتج بقى first we need central node to coordinate. We need coordinator. And what's the second advantage? Complexity coming with the central controller. We add some complexity. No. The second advantage appear if station 1, for example, doesn't have data to send. and already source one reserved for this station. But if station one doesn't have data to send, is it good or bad? It's bad because what about utilization of the channel? It's this amount of this slot already reserved for some station, but this station will not transmit. It's waste, and it's waste of resources, waste of the channel. Channel is ideal, reserve it for one station, and this station will not transmit at this time. That means that I'm wasting the channel. I leave the channel ideal without reason. In the random access, in random access, all of us are sharing the link, so anyone can transmit. So most probably we will not leave the channel ideal إلا بس of all of us, only if all of us has no data to send. In this case, station will be ideal. But here, some stations may have data, but I will wait some time ideal because some station don't have data to send. Okay? طب this disadvantage يعني appear يعني will be clearly appear when we name the throughput of the system is low. When the throughput of the system is low, what we mean by throughput of the system is low? Throughput number of frames per second. But when throughput of the system is low, it means that different nodes in the system transmitting less amount of data. يعني مثلا transmitting one frame now and wait for مثلا 3-5 seconds and transmit later 3-5 seconds. So we don't have large amount of data to transmit. Throughput slow, system lightweight, يعني we don't have very large data to send. In this case, it's better to go with random than we don't have large data to send. So who has data to send can send. In this case, the collision will be less and the channel will be utilized efficient. Then anyone has data to send will send. But when the throughput of the system is high, يعني all of us has data to send. In this case هيبقى مثلا ألوها أحسن ولا this reservation method؟ this reservation method. And if the throughput high, it means all of us need to transmit. But if we go for Aloha, all of us will send at the same time, so every time we'll have collision. But if all of us need to send and we make this reservation, us we will arrange things and we'll arrange things so no one will have collision and all slots will be reserved. So we'll use channel efficient in this case. This is similar to the idea of traffic sign compared to roundabouts. When a roundabout is efficient and when traffic sign is efficient. Roundabout is efficient when the traffic is light. So I don't have to wait for light traffic with no reason. Anyone can pass. But when there is jamming roundabout, I make big problems. It's better to reserve time for each route to go first. That is the main idea. We can go for random techniques if the throughput is low. We don't have enough, we don't have large data to send. So anyone can send, and possibility of collision will be low. But if the throughput of the system is high, it means that all of us need to send. It's better to go for some control techniques so we can coordinate and reserve slots before transmitting to avoid the collision. Okay. Second bad technique in controlled method, instead of reservation, we can make pooling techniques. So these pooling techniques work with technology in which one device, we agree that there is controller or one device to control central node, in which one device is designed as a primary station. I will define the main controller as a primary station, and other stations is secondary. So in pooling techniques, we'll have one primary station, and other techniques or other nodes will be secondary nodes. Okay, all data will be exchanged through the primary device. So anyone need to send should send the data to the primary device, and the primary device will forward the data to the destination to avoid collision. And instead of this node transmit direct to this node and this node transmit direct to this node, and collision may happen. In this case, we will have primary node. Anyone need to transmit will send the data to this primary node, and this primary node will forward the data data to the transmission. It is also there is no possibility of collision, and all communication go through the primary node. It's the responsibility of the primary device or the primary station or the primary node to determine which device is allowed to use the channel at a given time. And in this case, we have a select and pool. But if the primary want to receive data, it asks the secondaries if they have anything to send, and this is called pool function. So we'll use send. But if this is negative, I don't have station. B. Do you have data to send? Pool. Do you have data to send? In this case, station B will reply with the data. Yes. Responsible for delivering this data. And A, I received your data and I will forward this data. This is the first step, is pooling. I'm asking the stations to send. The other بقى, if the primary, if بقى the primary هي بقى اللي one of the stations it will send to the secondary to receive the data. And in this case, I will select one station to receive. For example, need to send to A. So I will ask yes, you need to send to send the primary البول function. Now, if بقى primary need to send, it will send to مثلا need to send data to the B بقى. If in this case بقى B receiver not transmitter. First case B transmitter need to send data. In second case in select B receiver. But primary will send to B. I select you to receive the data. Are you ready? If B is ready, it will reply with acknowledgement. Yes, I am ready to receive now. So primary will send the data to B and B will reply with acknowledgement. البولينج function مين idea pooling function برضه simple like reservation. مين idea pooling function. We have primary station and all other stations are secondary. And if any station need to send, the primary should send pooling function to this station. And if you have data, you will reply with the data. If you don't, you will reply with negative acknowledgement. This is the first step. And second step, if the primary need any station to receive data back, not to transmit data, will send select function. I select you to receive. If I am ready, if any secondary ready to receive, they will reply with acknowledgement. And in this case, the primary will send the data to the secondary. So if the secondary need to send, we will use the pool function. If the secondary will receive, we will use select function. And in the pooling function, we have primary stations and secondary stations. In the reservation, we have central nodes and we have reservation frame. During reservation frame, we make reservation for each station. In the reservation techniques, we use reservation frame to coordinate between nodes. Here in the pooling, we use a pool and select function to coordinate between nodes. That is the main idea of the controlled access technique. And they are very, very simple, and two simple techniques. Reservation using reservation frame to reserve the time when each station will transmit, and a pooling technique we will use select and pool function to coordinate between different nodes. Okay. Any question? Control techniques. Hmm. Yes.